Okay, guys, we're now going to go forward with deductive reasoning, which is what I was telling you is really, to me, the fun part. And in the beginning, it'll be sort of like arbitrary, and then it'll move to geometry toward the end. But this is your sort of little glimpse into the part of math that's called pure math. And basically, if people go beyond a bachelor's degree in math, they either go with pure math or they go with applied math. And for me, I went with pure math, and so this is kind of the part that I think is really fun. And this would just be a very kind of basic introduction to that. And it's the part of math with not so much on the numbers and more on the if-then. And the reason that math gets to stay pure all the time and doesn't get rewritten like we have to in science sometimes is because we never have to assume a thing is actually true. We just say, suppose it's true, then blank. And those results never change. It's always the case that if it were true, then blank, and if the beginning's not true, oh well, we still said a true thing. So, a conditional statement is a statement with the words if and then. If one thing is true, then another thing is true. So, oops, let me get a pen. So this is a statement using if, then. That's probably not a super formal definition, but that's basically the deal. The hypothesis is the bit that follows if. And really, a conditional statement can be made without using the words if and then, but it can be rewritten if and then. So you could say, for example, all women are human, and then the statement would be, if a person is a woman, then the person is a human. So it can be rewritten that way. And so in that case, the hypothesis is that it's a woman. The conclusion is the bit that follows then, assuming you've written it in this sort of if-then format. The truth value is the truth or falseness. I really need to reset my pen somehow. Anyway, so in the statement before, if someone is a woman, then they are a human, then this is true. And even though, I might refer to my female cat as a woman, they're actually not. If you look in the dictionary, woman means adult female human. So if you're a woman, then you're a human. No arguments from the boys. A counterexample is an example which proves a statement false. The example before is not a really good example for this particular thing because it sounds crazy, but basically if you could find a woman who was not a human, which you can't because they're defined to be human, then you would be proving it false. If the statement had been reversed and I'd said, if you're a human, then you're a woman, then all you have to do is find a man, because then you have a human, and he's not a woman, so that's a counterexample. So we want to give a counterexample for this. If the month has 30 days, then it is September. So what we want to find for a counterexample is a month which does have 30 days, which is not September, because then the statement is false. So if you know the little 30 days has September, April, June, and November, we could say, okay, here's a counterexample, April. Oh my gosh, April. And that's my counterexample. Could January be a counterexample? The answer is no, it can't, because January has 31 days. So it doesn't fit the hypothesis. So for a counterexample, you need something where the hypothesis is true and the conclusion is false. We want to underline the hypothesis and circle the conclusion. If it is Tuesday, so we're going to underline that, that's the hypothesis, then the cafeteria is serving nachos. So that's the conclusion, is the cafeteria is serving nachos, because that's the thing that follows the word then. Okay, so a conditional statement is one that can be written if then. So if A, then B. A and B represent sentences or properties. So in the previous example, A was someone is a woman, and B is they are a human. The converse of a conditional statement is where you switch it. So then you say, if B, then A. So in the previous example, it would have been, if you're a human, then you're a woman. And no arguments from the ladies, that one's false. The inverse is where you negate them both. Negating means saying not. So if not A, then, running out of space, not B. So if A is false, then B is false. If someone is not a woman, then they are not a human. Of course, again, with the man, that's not true. The statement formed by doing both is called the contrapositive. We'll talk about the truth relationships more in a minute, but this is if not B, then not A. So in the previous example, if you're not a human, then you're not a woman, which is true. And a biconditional statement is one where both directions are true. So if A, then B, and if B, then A. And it's stated A, if and only if, which is usually just IFF, B. So this means A if B, so B implies A, and A only if B, so A implies B. So if this one is written with an arrow this way, and this is written this way, then this one, there's a little symbol that means not, and it's shaped like this. So not A implies not B. So you would read implies with this arrow, but it means if the first one, then the next one. Not B implies not A. Then this one is a double arrow. They both imply each other. They're equivalent statements. They both force each other to occur. If we were doing this together, I'd have you guys come up with the if-then statement. So mine might not be the most interesting, but let's make as a statement, if you will be in 11th grade at, we're out of room, PISD Academy High School next year, then you will have me for math. Okay, so the conditional statement is, if you will be in 11th grade at PHS next year, so I'm going to just put 11th PHS 14-15, then, whoops, Erwin Curry for math. Okay, so that is true unless something horrible and unforeseeable happens. Then if you were in 11th grade next year at Plano Academy High School, then you will have me for math. That's true. The converse is where we say it in the reverse order. So if you will have me for math, then it means that you will be in 11th grade at Plano Academy High School in 1415. I'm going to put this one as false because if this is true, it means that I would die before next summer because I will teach people after next year. So that one is false because you can be someone who's going to have me for math and not be someone who will be a 11th grader at Plano Academy High School next year. The inverse says if you will not in 11th grade, oh my goodness, if not in 11th grade at PAHS in 1415, then you will not have me for math. Well, that's not true because someone who's in 9th grade this year and will therefore be in 10th grade next year will still have me for math, and they are not in 11th grade at PAHS next year, but they will have me for math. So that's an example where the hypothesis is true and the conclusion is false, so it means the statement is false because there's a counterexample. The contrapositive says if you will not have me for math, so sad, never ever, then you're not in 11th grade at PAHS next year. Well, that's true. If you're never going to have me, then you're not going to have me next year, so you're not going to be in 11th grade there next year. So this one is true. This one would say that 11th graders PAHS next year and people who will have me for math are the exact same set of people. Which, of course, that's not true because of the people that I will have the year after and after and after. So this one also false. Okay, I attempted to fix my pen, so we'll see how it goes. For the next sentence, we just finished up Father's Day, so let me go with that. Let me say the statement conditionally is if it is Father's Day, then it is June. That is true because Father's Day is always in June. The converse would be if it is June, then it is Father's Day. Well, there's a whole lot of June going on that isn't Father's Day. Father's Day is one day of the month, and for example, today it's June, but it is not Father's Day, so that one's false. The inverse is if it is not Father's Day, then it is not June. That has the same counterexample as the converse because right now today it is not Father's Day, so the hypothesis is true, but it is June, so the conclusion is false. So this is again false. The contrapositive is if it is not June, then it is not Father's Day. Okay, so if it's not June, then it definitely can't be Father's Day because Father's Day only occurs in June, so that one is true. The biconditional would say it is June, or no, it is Father's Day, Sorry, my pen is making me feel crazy. Ugh. Father's Day. If and only if June, so that would mean that if it's Father's Day, then it's June, and if it's June, then it's Father's Day. Since one of those is true and one of those is false, then the biconditional is false. Okay, so let's look at this, and we want to just decide if things are true or false. That'll be good. We can have a rest from my crazy pen. So here's the conditional statement. If it is Saturday, then it is the weekend. That's true. Every Saturday it is weekend. The converse, if it is the weekend, then it is Saturday. That is not true because Sunday is the weekend and is not Saturday. So that one's false. Inverse, if it is not Saturday, then it is not the weekend. Same counterexample, because Sunday is not Saturday, but Sunday is the weekend. So, false. Contrapositive, if it is not the weekend, then it is not Saturday. That's true. If it's not the weekend, it's a weekday, so it's not Saturday. True. Conditional, if you were in high school, then you were in the 9th grade. That's false, as you all know, because you were in high school and you were not in the 9th grade. The converse, if you were in 9th grade, then you were in high school. Well, that is true, because 9th grade is part of high school. The inverse, if you were not in high school, then you are not in 9th grade. That's true, because then you're either below 9th grade or beyond 12th grade, so you are not in 9th grade. If you are not in 9th grade, then you are not in high school. Again, I think that you'd argue that you are in high school. If an angle is a right angle, then it measures 90 degrees. That's true. That's the definition of a right angle. If an angle measures 90 degrees, then it is a right angle. Again true. Again the definition of a right angle. If an angle is not a right angle, then it does not measure 90 degrees. That is true, because if it did measure 90 degrees, then it would be a right angle. If an angle does not measure 90 degrees, so it's something other than 90, then it is not a right angle. Again, true. Okay, so if you look both on the previous 2 pages and on this page, the conditional and the contrapositive have matched, whether true or false, every time. And the converse and the inverse have also matched every time. And if you think about it, the inverse here is the contrapositive of the converse. Okay, so if you take the converse as the conditional statement, if it is the weekend, then it is Saturday, then the contrapositive of that is if it is not Saturday, then it is not the weekend, which C is the inverse. So these two are each other's contrapositive. These two are each other's contrapositive. And it turns out that a statement and its contrapositive always have the same truth value. So a statement and contrapositive have same truth. And that's just always true. Decide which statements from number 1, which is the thing above actually, have a biconditional statement. So to be biconditional, it has to be that the conditional is true and the converse is true. And that only happened on the last one there. So we can say an angle is a right angle if and only if it measures 90 degrees. Okay? So we're given a biconditional statement now, and we want to write it as a conditional and a converse. So two lines are perpendicular if and only if they meet at a 90-degree angle. So conditional. If two lines are perpendicular, then they meet at a 90-degree angle. The converse is if two lines meet at a 90-degree angle, then they are perpendicular. Two coplanar lines are parallel if and only if they have the same slope. So if two coplanar lines are parallel, then they have the same slope. I'm actually going to quit. I'm not going to write this last sentence just because this strangeness. The converse would be if two coplanar lines have the same slope, then they are parallel. So the converse is if two coplanar lines have the same slope, then they are parallel. Okay, so this one we want to circle the correct counterexample and then explain why the other ones are not counterexamples. So we want a counterexample to if a country borders the United States, then it is Mexico. So what we need is something that makes the hypothesis true and the conclusion false. That's what a counterexample always is. So we need a country that borders the United States, but isn't Mexico. Canada does border the United States and is not Mexico. Alaska is not even a country, and Spain definitely does not border the United States. So the only one that's a counterexample is Canada. So I will circle Canada and hope we sufficiently discussed the reasons so I don't have to write them. A counterexample for each of the following: if an angle is not acute, so it's obtuse, then it measures 93 degrees. So the acute means smaller than 90, and not acute therefore means bigger than 90. So I don't know, 91's bigger than 90 and is not 93. So anything between 90 and 180 that isn't 93 is a counterexample. If a triangle is isosceles, remember that means two sides are equal, then it is equilateral. That means three sides are equal. So all I need is for two sides to be equal, but not all three. So I'm going to claim those two sides are equal and pretend anyway that they are. But that other one is much, much smaller, not equal. That's an isosceles triangle, which is not equilateral. If two lines intersect, then they are perpendicular. Remember, we decided for them to be perpendicular, they have to intersect at right angles. So let's make them intersect at not right angles. Those don't intersect at right angles, but they do intersect. So they are not perpendicular. That brings us to the next one. So I'm going to get this one up and see if I can ever figure out what's going on with that pen, and then I'll start on this one.